All right, here is your second property of exponents, or exponent rule, which you could call them as well. So we have products with the same exponent, except this time notice how I don't mention the bases, okay? So I have a base of a, and I raise it to the n power, and I'm going to multiply it by another value with a different base, but raised to the same exponent. We can simplify this by multiplying the two bases together and then keeping the same exponent. Okay, so notice how the bases are different, but the exponents are the same. So an example with numbers. Let's take a look. Let's do 3 to the second power times 4 to the second power, or 4 squared. Notice how the exponents are the same number, but the bases are different. The bases have to be different to use this rule here. So what I'm going to do is I'm going to multiply my bases, so 3 times 4, and I'm going to raise it to the second power. And so I know this is equal to 12 squared, which we know is equal to 144. Let's try an example with negative exponents. So, let's see. Let's go 6 to the negative third power times times 3 to the negative third power. Again, notice how the exponents are the same. So I'm just going to take my bases and multiply them together and keep the same exponent. 6 times 3 is 18. 18 to the negative third power. We don't like negative exponents, so following the negative exponent rule, I can rewrite it as 1 over 18 to the third power. And the negative sign is no longer there. Punch that into your calculator. 18 to the third power is 5,832. So my final answer is 1 over 5,832. And there we go. All right, let's do an example with variables. We'll do x. Let's stay with the negative exponents. Let's do x to the... Actually, I'll do 1 positive, 1 negative. So x squared. No, let's do x to the 12th times y to the 12th. Right? I'm just multiplying my bases together, and I keep the same exponent. I can rewrite this as xy to the 12th power. Now, be very careful here, because if you write xy to the 12th power, that looks like the exponent of 12 only applies to the y. So that's why I leave this xy in parentheses. So do not do this. That means something else. So our final answer, x times y to the 12th power. Okay, now let's take a look at a negative example. Let's do m to the negative 8th power times n to the negative 8th power. So again, just multiply your bases, n times n, and keep the exponent. So we can rewrite this as mn to the negative 8th power, but we do not like negative exponents in our answers, so following the negative exponents rule, I can just write the reciprocal of that, and then keep that in parentheses and raise it to the 8th power. And there we go. And there you have your second property.